Hi, in this video we're going to continue with our financial math and using our spreadsheet formulas. And we're going to use the same formulas we've been using, the future value formula and the present value formula. The difference is now we can have monthly payments. So we're going to look at, you might have an initial deposit or not. You could also maybe have monthly payments or not. And see how to put those into the formula. So here's an example. Just like we've been doing, we're going to write out our formula with all the inputs. You want to save $100 per month at an annual rate of 8% interest. How much will you have after 15 years? Okay, so first question, do we use the future value or the present value? Let's figure out what we know. We've got our rate, we've got our time. How much will you have after? So I guess that after is a big key word there, right? So what we want to know is the future value. We want to know the future value. We're not putting in a big deposit, so our present value actually is 0. And then we're going to put in $100 each month. So this 100 we haven't used yet. This is our first time using the payment argument. You can use it in either one. Okay, so we're going to use future value because we want to know how much we're going to have in the future. So we're going to use equals, I'm going to go over here, equals future value. Our rate is 0.08. Okay, now this can be a little bit tricky on the payments. So if we're putting in a payment per month, then it has to be compounded per month. So it says annual rate of 8% interest, but we still have to divide by 12 like we were doing with the compounding. So your payment period has to match your compounding period for this formula to work. If you are making a payment quarterly, then your compounding is quarterly. So per month, so that means we're going to use 12 in both places. Now, how many payments are we going to make? Or how many periods are there? 15 years times 12. And now we get to use that payment. So it's been 0 so far, but now we get to put in $100, saving $100 a month. And our present value is now 0. So where you put that 0 makes a big difference. Still not going to use the type or the beginning or end of the month. I'm not going to worry about that. Okay, let's see how this comes out. Equals future value 0.08 divided by 12, comma, 15 times 12, comma, 100, comma, 0. Okay, let's see if this makes sense. 100 a month, 15 years. Seems like a lot of money. $34,603.82. 8% is a very good interest rate. That's challenging to find that nowadays. Let's do just a quick little check. How much will you have after 15 years? I want to know just how much money we've put in. So 100 times 12 times 15. I'm kind of curious. So we can use a spreadsheet to do any old calculation we want. Equals $100 times 12 months times 15 years. Okay, so that's $18,000 just by putting in your $100 every month. So that's a lot. And then now that does make sense to me that because we've seen it double, or our money double before, So it does make sense that it's not quite double. But okay, seems more reasonable to me now. So saving little bits, even though $100 a month is not that little, saving pays off. So let's write that out. We will have $34,603.82. Oops, I switched those. $82 in 15 years. Now, some questions might actually ask you, some problems might ask you, how much did you earn in interest? So just on the side, I kind of want to write down what we did. 34,603.82. If we subtracted all of our payments, that came out to $18,000. And I want to see what that is. So if I go 32,603.82. Oops, I forgot to put my equal sign. Telling it I want to calculate something. Minus 18,000. That's 14,603.82 in interest. Cool, huh? So that was the 100 times 12 months times 15. It's the 18,000. All right, so you might come across a question like that. I just had to know. Okay, so let's do another one. Let me cover this up before we get to our payment formula. It's going to be another formula. You want to save $1,000 now and $50 per month for 10 years. How much will you have if you find an account with 7% interest? Okay, so this is a realistic scenario too. Let's say I've got my tax refund, or I got an inheritance or some money. I want to put some down now to start, kind of jumpstart my savings, and then a smaller amount per month. Okay, so 1,000 now, that's my present value. Let's say 1,000 now. 50 per month, that's my payment. 10 years is my time. And we've got our rate, okay? How much will you have? So this is implying, even though it doesn't say, it's implying this is in the future. How much will you have in the future if you find an account with 7% interest after 10 years? So our future value is what we're trying to find. Okay, so let's go over here again. Equals future value. Our rate always comes first, so 0.07. This is monthly again, per month. So that's 12. This time it's 10 years, so 10 times 12. Okay, the third thing is the payment. So the payment comes first, which is $50. Then the present value is 1,000. So here's a situation where we have both a payment and a present value. Okay, let's put it in. Equals future value 0.07 divided by 12, comma 10 times 12, comma 50. Getting two-handed now. Getting faster on this. Comma 1,000. Does that look right? $10,663.90. So that was 10 years, not as long as the 15, putting in 1,000 now and then 50 a month. So we would have $10,663.90 in 10 years. Okay. So those are two more examples using, these are both using the future value formula, but having a payment involved. Okay, now let's move on. There's one last formula that we're going to use in spreadsheets. I know there's been a lot of formulas. Just remember, you don't have to memorize them. You just have to identify which one to use, because that's real life. You can always look up a formula. Okay. This one is really, really useful though. In fact, you might use this one more than anything else. This is a payment formula. So it actually calculates a payment. So this is used for if you want to find out how much you need to put in every month. And we'll also use it for loan payments later in the next section. Let's look at an example. You can see the inputs are pretty much the same thing we've been doing. Rate, number of periods. We don't have payment because that's what we're trying to find. Present value, future value. Okay, so let's look at this example. You want to save $30,000 for the down payment on a house in 5 years at an annual rate of 5% interest. How much do you need to set aside per month? Okay, so this is where you would want to use the payment formula. And then you see, well, is that realistic? I don't know. So let's try it out. So equals PMT for payment. Now we need to figure out everything here. So 5 years is our T. It's our time. Our interest is 0.05 per month. So we know our compounding is going to be 12. We want to save 30,000. Is that, we have 30,000 now, or we want that in the future? We want that in the future, right? So this is our future value. What's our present value? 0. We have nothing. We have nothing now, and we want to figure out how much do we need to save in order to get 30,000 later. Okay, so our rate is going to be the 0.05 divided by 12. Number of periods, we want to try to do this in 5 years, so 5 times 12. Next is the present value. Okay, so present value is 0. We have 0 right now. I like that these go in order from now to later. Present to future. That helps me remember the order. So we have 0 now. We want to go to 30,000, and I can't put that comma in there even though I want to. Okay, this should tell us our monthly payment. Do you want to guess what you think, how much you think it'll be? Okay, so this formula is equals PMT 0.05 divided by 12. 5 times 12. Remember, these two numbers always have to match. If it's a monthly payment, it's going to be 12. So that's the most common. You could possibly make quarterly payments or yearly payments. Okay, present value is 0. Future value is 30,000. Okay, $441 a month. I thought it might be more than that. $441.14. So this is where you could, if you want to save up to buy a house, you could start running some scenarios. How much, when do you want to have the house? And then how much can you afford to put away per month? Also, how much interest can you get? What's the highest interest rate you can find? Okay, so we would need to save $441.14 per month. Okay, so that's a really useful question. Here's another one. Your company needs $2 million for an expansion project in 5 years. How much should be deposited quarterly? So here's a different example. Quarterly in an account that earns 8% interest compounded quarterly. Okay, those match. Okay, let's try it out. So how much should be deposited quarterly? So that tells me that's a payment because it's something that's happening over time. Okay, what is our rate? We've got 8% divided by 4 because it's quarterly. 5 years again, same as the other one. 5, but this time times 4. Okay, present value, future value. Do we have any money now? It doesn't say we do. Just saying, oh, we want to expand. We need this $2 million. So we've got nothing for our present value, and this is our future value. That's what we want to have. 2,000,000. No commas. All right. See what we get. How much do you think it's going to be? Like $2 million. It's going to be in the thousands, right? Plus we're only doing quarterly, so that's going to be a big chunk every quarter. It would be smaller if it was per month. Let's try it. Equals PMT, payment, 0.08 divided by 4, comma, 5 times 4, comma, 0, comma, 2,000,000,000. Wow. $82,000. $82,313.44. I mean, that's $2 million in 5 years. That's a lot of money, right? If you just did $2 million, I'm just playing around now. If you just did 2 million divided by 5 years divided by 4 quarters. What is that? 1, 2, 3. That's $100,000 a quarter. So if you weren't getting any interest at all, you would have to put in $100,000 every quarter. With the interest, you only have to put in $82,000 every quarter, and then the interest compounds to make up the rest. Okay, the company needs to save, so instead of taking profit, then they would need to put that money in an account. They would need to save $82,313.44 per quarter. Okay, so that's an example of using the payment formula, and then we also use the future value formula but putting monthly payments into it. So I'll see you in the next video.